I'm going to practice kinetics. Question number 1 reads, in order for any chemical reaction to occur, there must always be, answer A reads, a bond that breaks in a reactant particle. Letter B reads, a reacting particle with a high charge. Letter C, effective collisions between reacting particles. And letter D, a catalyst. Now, if this question's confuddling you a little bit, I want you to just stop here, go to the lecture slides and review them very quick. There was an Edpuzzle on it. It was about 1.5 minutes. Review that Edpuzzle. This way you can have a moment to reflect on this. Okay, the correct answer here is going to be letter C, that effective collisions between reacting particles will form any chemical reaction. We have to have collisions of particles together or of compounds for there to be a chemical reaction. Number 2 reads, which conditions will increase the rate of a chemical reaction? So what conditions did we learn about from the virtual lab that we did? What conditions are going to increase, keywords there, increase the rate of a chemical reaction? So how fast we're going to get products from the reactant. Letter A says that a decrease in temperature and a decrease in concentration is going to increase the rate of reaction. Letter B right here says a decrease in temperature and an increase in concentration is going to increase the rate of reaction. Letter C says an increase in temperature and a decrease in concentration is going to increase the rate of chemical reaction. And letter D says increased temperature and increased concentration will increase the rate of chemical reaction. Take a moment and think about the virtual lab we did and the different variables in it and answer this question. Okay, the correct answer is letter D, because an increase in temperature will cause the particles to move around a lot faster. Therefore, there is going to be an increase in the collisions of these particles. And also, if we increase the concentration, we'll increase the amount of particles in there. So, increasing the amount of particles in a solution is going to increase the probability or the rate at which they bump into each other. Same for temperature. So therefore, letter D is correct. And I understand some of you might have picked letter C, but remember, if we decrease concentration to a point that there's not enough particles to even really bump into each other, even if they're moving fast due to an increase in temperature, it won't matter. So the correct answer still remains D. Number 3 reads, when a catalyst is added to a reaction, the reaction rate is increased because the catalyst does what? Is it that the catalyst does what letter A says and it increases activation energy? Is it because it's letter B and that it decreases activation energy? Is it letter C that it increases potential energy of the reactants? Or is it letter D that it decreases the potential energy of the reactants? Now, this was about 3/4 of the way through the other Edpuzzle lecture slides, so I hope you've gone through those to take a look. If not, give this a chance. Okay, the correct answer is letter, which one? B. It decreases the activation energy. And remember, this is the amount of energy that we would need for these reactants to form a product together. So we decrease the amount of energy it requires to do that. Number 4, given the reaction below, magnesium, and then we got a compound there with hydrogen, nitrogen, and oxygen. And then the product side, strangely, has magnesium, and now it's bonded to nitrogen and oxygen, and we have hydrogen by itself. So you might remember this as a single replacement reaction, where we have one element by itself at the start, magnesium, and then magnesium actually is bound to a different element, or in this case, a different compound, and we're left with a different element by itself. So this is a single replacement reaction. But at which temperature will the reaction occur at the greatest rate? So really think about that virtual lab. Think about the temperature variable. Did reactions occur more frequent at higher temperatures or at lower temperatures? All right, the correct answer here is letter D, because as we increase temperature, we are also going to increase the frequency that particles are heading into each other, back and forth, back and forth, back and forth. And therefore, the reaction rate will have its greatest rate at the highest temperature listed here, because the particles will increase in entropy or chaos, so they'll be moving around a lot more. Therefore, reaction rate increases. So now we really need to make sure that we've opened up another tab or that you have your paper copy of the reference table available to you. Because at this time, we're going to need, for the rest of the questions, table I. Now, number 5 says, which substance is formed through an endothermic reaction? Now, remember what I said before. Endothermic reactions. Hold on, sorry. There we go. Endothermic reactions are ones where the reactants, they need to have a little bit of oxidation energy. And then the products will actually have more energy than the reactants had because they needed to absorb energy to form. When in contrast, an exothermic reaction, the reactants have a lot of energy. We have a little bit of activation energy required, and then the products down here actually needed to release energy to form. So, which substance is formed through an endothermic reaction? Now, Ms. Wong wants to remind you, you have to remember what an endothermic reaction is here and what helps you determine it on table I. So if we go to table I over here, remember that anytime we see a negative number, that is an exothermic. Exothermic if it's negative. Endo will be positive because it's absorbing energy. So let's take a look at these 4 different answer choices. We have hydrogen and iodine, HI, as a gas, H2O, liquid, NH3 as a gas, H2O as a gas. So let's very briefly go back to table I, and let's take a look at the products that are listed over here on the right side of the arrow. So first things first, we're going to look for HI. And you can find these fairly easy after you use the table for a little bit. HI is right down here. And if you take a look, it has a positive number. So therefore we know, is this endo or is this exo? And then we go back and we're going to look up the 3 others, H2O. There we are. Now, when you look at H2O though, you'll notice there's a gas and a liquid. So make sure you're looking at the correct one. For instance, H2O is liquid. When we have 1 mole, we're going to have half this number. And H2O is a gas. We're also going to have to half this negative number as well. Now, the other number was NH3, which is also a negative number. So in this case, if you were taking the Regents exam, you would look at these 4 answers and you would say, okay, we got 1 positive one, which is endothermic. We have 1 that's exo, exo, and exo. So the correct answer is letter A. Question number 6 says, based on reference table I, the formation of 1 mole of which substance releases the greatest amount of heat energy? And there's 2 tips to this question. 1, what will be the key word? It's going to be that the substance releases energy. So is this endo or is this exo? Is it going to be a negative delta H on table I or a positive delta H? Now that word helps you in that way. So take a moment. Which one is going to be an exothermic reaction and which one's releasing the greatest amount of heat for 1 mole of the substance being made? Now the correct answer is going to be C2H6 And the reason for that is because when we go over to table I, we're going to see that 1 mole of C2H6 creates negative 84 kilojoules. Now, for anyone that answered that it was going to be NH3, you need to pay attention to the coefficient in front of there telling us that we have 2 moles of NH3 being created to form negative 91.8 kilojoules. So in this case, you need to divide that number by 2. In number 7, in which reaction, according to reference table I, do the products have lower energy content than the reactants? So look at table I, and you're going to be looking for either a exothermic reaction or an endothermic reaction. Which one? Based on the fact that we're looking for the products are going to have a lower energy than the reactants. So take a look at this little graph right here again. Which one has the products with less energy than the reactants? And using table I, are we looking for a negative delta or a positive delta? Okay, the correct answer is going to be letter A up here, CO2, because when we go over to table I and we find CO2, for 1 mole of CO2, we're at negative 393.5, but every other answer that they gave us, C2H2, 2NO2, and 2NO2, 2NO and 2NO2. All of those on here, when you look, are going to be positive. So it's not exactly an exothermic reaction, is it? Exothermic reactions on table I are always going to be negative. Number 8, identify the information in this equation that indicates the reaction is exothermic. So take a look at this reaction below where we're forming 2 moles of water. Is it exothermic? How do we know that? Give me one piece of this reaction that gives you that. Try number 8 again. In which reaction, according to reference table I, do the products have lower energy content than the reactants? I'm reading it again. Identify the information in this equation that Identify the information in this equation that indicates the reaction is exothermic. So take a look at the reaction below. What piece of this reaction shows that it's exothermic? Number 9, compare the potential energy of the reactants to that of the products in this reaction. So take a look at the reaction again from number 8, and I want you to think about which graph represents this reaction. Is it going to be the graph on the left or the graph on the right? And then I want you to tell me why you know that. All right, everybody, great job. Thank you very much. Hope you enjoyed this Edpuzzle.